So it's not like you're spending class time like looking for the paper.
Right.
Okay, speaking of papers, any chapter 7 that I come back from homework, anybody have an issue? They haven't all been perfect, I'll tell you that. Anybody have an issue? Okay, then let's get on with our notes. We all need a calculator. Does everybody have a calculator today?
I forgot to calculate.
Abby Cody, girls, both of you. Here's what we're going to do today. We are going to use our calculators.
I'm so excited. It's on calculator.
We're going to use our calculators to solve systems of equations using a process called Gauss-Jordan reduction. Now, the good news for you is you don't have to learn how to do it by hand. Before the calculators, we had to do all this by hand. We're going to use the process, but the calculator is going to do the work. So, yesterday, we used our calculator to do A inverse times B. Remember that? Okay. Now, we're going to set up a matrix, just one, that has everything in it. So, for problem 4A, I'm going to have 1, 1, negative 1, 2. See what I did? I put the X, Y, and Z and the equals all in one matrix. This is called an augmented matrix. Anybody know what to augment means? What does that mean? To lengthen, right? Make bigger. So we're making a longer matrix that will hold all of the numbers in the equation. So then I'll have 2, negative 1, 3, 14, and 3, 1, 1, 14. Now, if you set up a matrix like this, you cannot do this process. Because remember, in order to find an inverse, you need a determinant, and in order to find a determinant, you have to be square. This is not a square matrix. What are the dimensions of this matrix?
3 by 4.
3 by 4. 3 rows, 4 columns. All right, but luckily we don't care about that. We're going to use Gauss-Jordan. So now what I want you to do is type this matrix into our calculator. So remember how that works. We go to second matrix, over to edit, and I want everybody with me here. Math is not a spectator sport. So over to edit, enter. What are the dimensions of this matrix? You just told me 3 by 8. Okay? Now put them in. So put in those numbers. Now, do you remember from yesterday? Where's your calculator? Sir, where's yours?
It's at my house.
Okay, we don't share. We all gotta be typing. So now you got a pencil, write your names on the board. The board is infamy over here. Okay. Once we get it all, does it say low batteries? It does?
Mm-hmm.
All right, we can do it. Okay. All right. Once we get that last number in and press press enter. You remember we second quit? Now, this is where things are going to be a little bit different. So we're going to go back in, second matrix. Now, we're going to do something. We're going to do some processes with this. So go over to math. And then all the way down, it's quite a ways down, find the button that says RREF. Find it? It's quite a ways down. I'll tell you what that means in a minute. But press enter. So when you do that, on the screen, on your home screen now, it says RREF, parentheses. Okay? So, second matrix, enter. You want an RREF matrix A. So now that's what it says on your screen. Press enter again, and it pulls up a new matrix that looks like this. We're going to do another one. If you missed a step, just pay attention where we are now so you don't fall farther behind. Remember, the first matrix you put in had one X, one Y, one Z. In other words, these were the X numbers, these were the Y's, these were the Z's. Well, that hasn't changed. The difference is, what does that top equation now say? 1x equals 4. It says x is 4. And what does the middle one say? Y is 0. And the bottom one says z is 2. So the answer to the question, like the corner of the room up there, is the point 402. Now, yesterday, we accomplished the same thing doing it this way. So you will develop your own favorite way of doing it. This uses two separate matrices. This uses one big one. RREF stands for Reduced Row Echelon Form. When you put a matrix into reduced row echelon form, you can read the answers off the side because you have 1, 0, 0, 0, 1, 0, 0, 0, 1. That's what it means to be in a reduced row echelon form. Everything underneath the ones or above the ones is a 0. So you can just read off your answer. X equals Y equals Z equals.
Will the X always be in row 1?
X will always be wherever it was when you put in the equations. So we put in our equations X, Y, Z. So the answers are going to come out X, Y, Z. So 1X, no Y's, no Z's equals 4. That's what that top row now says. Okay? All right.
Why wouldn't they just make it to where when you press enter, the 4 showed up in the one, the X in the first row, the 0 showed up where the 1 is in the second row. Like I get it, like you're all reading over, but.
Well, here's the problem. Reduced row echelon form means that number has to be a 1. That number has to be a 1. That number has to be a 1. So, I suppose somebody could write a program or something and make that happen, but it's not going to work with this button ever because this button means you're going to get these ones. If I'm doing the problem by hand, I'm going to have to get these ones by adding these rows together, multiplying, doing all kinds of work. Okay? You guys are lucky. You've been born when I was born. Oh, Lord. Even when I first started teaching, you get all this by hand. All right. Let's look at the next one. Now, what is a little bit different about the next one?
There's a W.
There's 4 variables. So you need to decide, and it doesn't matter, but you need to decide if you're going to put it in as X, Y, W, that is completely fine. That's completely fine. But you could also put it in if you're like, sort of, what's that word, anal about stuff. You could put it in as W, X, Y, Z if you want them in order. That's completely up to you. All right, here we go. First equation. X, Y, Z, oops, no W, so what do you think that means? 0, 4. 0, 1, 0, 1, negative 4. Everybody following that second row? 1, negative 1, 0, 0, 1. And 1, 0, 1, 1, 1.
So are we all gonna get different answers?
No, no, we're all gonna get exactly the same answer. Exactly the same. Now, your matrix will look a little different, Jeff. If you, like I left my equations in the order X, Y, Z, W. If you changed yours and made it W, X, Y, Z, your matrix will look a little different, but X is still gonna be X, Y, Z, and so on. All right, second matrix. Those of you who got lost last time, pay attention. Second matrix, edit. How big is this guy?
4 by 5.
He's a 4 by 5. 4 rows, 5 columns. All right, so put it in. After you get the last one in, the second click, right? Press enter, and then second click. Is everybody there? All right, so then second matrix. We'll run over to where math is highlighted at the top, not edit, not names, but math highlighted. All the way down to RREF, arrow down to RREF.
No,
Press enter. Right? Now the screen says you want me to RREF something. So second matrix. A is highlighted, that's what you want it to RREF, so press enter and enter.
So,
Just a minute. Now, if you use the same variable arrangement that I did, which was X, Y, Z, W, then X is 4.5, Y is 3.5, Z is 4, and W is negative 7.5, right?
You said V.
Guys, anybody match that? Okay. If you change the order of your variables, if this is W now, if you change it so that's W, then your negative 7.5 is going to be right here. X, Y, Z, and W are what they are. They might be arranged differently in the matrix depending on how you put it in. Now, we like to organize our answers and write them as, in this case, what, an ordered quadruple or whatever. But in my case, I am going to have to label them because I didn't do it in alphabetical order. When somebody sees this setup here, you know, comma, all these numbers in the parentheses, they automatically assume it's alphabetical order. If it's not, then you need to say it.
So I just checked all of my inputs and they're all correct with how I had it, but I'm not getting that.
Okay.
I'm
I'm gonna tell you something, sir, I don't wanna hurt your feelings, but the calculator doesn't make mistakes.
Yeah, I'm just not sure where
So
I
this
just checked
is-
my input.
This is human error.
Yeah.
Alright, while I'm messing around with this, would you take a look at the next one? And go ahead and get the next one set up. Okay, sir, I have no idea where these numbers are. These are, this is not the numbers. Those are not the numbers. Why is that? Okay. So we're working on C, right? Everybody's typing it in.
Now do the next one. Okay. Tell me what you.
No, this problem isn't gonna be able to
All right, everybody. What? I heard somebody say it's not right. Something is not right. We have trouble in River City. When I RREF this guy, this is what I got. Now, if anybody was listening to me talking to Jeff, you can tell me what's wrong with this. What's wrong with it? There's no one right here, right? Now, what difference does that make? Well, I want you to stop and think about this for a minute. Remember, the top row, I erased it before, but the top row, like in the last matrix, looked like this. I don't know what that number was. But what did that say to me? That literally said x equals 6. And then this one had a 1 here, and that one said y equals 5, and so on. Well, I want you to look at this bottom row. What does it literally say?
There is no
0 z's equals 0. Isn't that what it says?
Yes.
Now, wait a minute. If 0 z's equals 0, what's z? What can z be? Well, z could be 0. Could z be 1? Z could be anything, couldn't it? Could z be anything? All right, so hang on to your hats. We're getting ready to learn how to write down this answer. If you say all real numbers, you will get a big fat purple or pink or whatever color I'm using, X. All right, we're done with that. We're not doing that. We're going to write the answer as a geometric shape. So, Jeff, what was your question?
I'll ask after.
Okay.
Circle.
So, when this happens, and you get an entire row of zeros, then that means you are going to have infinitely many solutions. And what do those solutions look like? Well, you just told me that z can be anything. And you're right. So we're going to write that like this. We're going to say z is z. Z is whatever it is. It can be anything. Now, back up a row. What does that middle equation literally say? Write the equation. What does it say?
Three.
Y plus 3z equals negative 13. Remember, these are the x's, y's, z's equal. That's how you wrote your equations, right? Or your rows, I mean. So does everybody see 1y plus 3z equals negative 13? Which means y equals negative 13 minus 3z. Okay, so z can be anything. So if I pick a number, okay, z is 5, then that will give me a y value, right? But if I pick z equals 4, then I will get a different y value. The value of y depends on the value of z. All right, well, what about the top row? What does it say?
X minus 4z.
X minus 4z equals 23. So what does x equal?
X equals 23 minus plus 4z.
There you go. There are infinitely many solutions, just like you said from the beginning. But the ordered triples, the points, x, y, z points, depend on the value of z that you choose. So how do we write that? Well, we write it like this. I'm going to erase that. So we write it like this. We say x, y, z equals two things, a number and a z value. Now think about that for a second. It's very easy. We're just organizing our answer. X is 23 plus 4 z's. So 23 plus 4 z's. That's our x value. Now what's our y value?
Negative 13.
Negative 13 minus 3 z's. Now don't freak out. This is the easiest one of all. Isn't that 0 plus 1z?
Yes.
So 0 and 1z. And that's how we write our answer. Mrs. Ford, what does that mean? I mean, in terms of like the world, what does that mean? Well, remember yesterday we talked about these guys, these equations are planes. Talked about the front board, the ceiling, and the sideboard. When it all works out perfectly, those planes are intersecting in a single point. When it doesn't work out perfectly, they're intersecting some other way. These three planes are intersecting in a line. This is a line, believe it or not. This is a three-dimensional equation of a line. So think about it like this. Reese, hold this paper for me. She's got a plane. She's going to hold it up high so you can see it. She's got a plane, and I've got two more, and they're intersecting like this. They're like a pinwheel. They're coming together in a line. Cool, 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 cool. One more thing. There's another thing that can happen. This is the ideal. The ideal is this. Okay, that means 1, 2, 3 is my answer. We just had this situation. Okay, and it's not ideal, but it's solvable. You get infinitely many solutions. It looks like this. The other thing that can happen is you can get this. Now, tell me about that.
0 z equals
Okay, so what did you say, Alexis?
0 z equals 1.
0z equals 1. That's what that says. Can 0z equal 1? No. So what's happening in this system? they're not intersecting. They're not intersecting. Think of it like, hold this up again. Think of it like this, like a tent. You got planes intersecting, but not all three of them intersect together. That's what's happening in that bottom one. Okay, Jeff? No solution. So this would be no solution.
Would there ever be, would you say, if the bottom row is all ones, would you call that?
No. The bottom row, when you RREF, the bottom row will never be all ones. Because when you RREF, the first number in the row will be a 1. But there can't be, so under the 1, you can only have zeros. Right? So that these aren't ever going to be all ones.
But that would technically, would that mean that they're all equal?
All equal to each other? No, not necessarily. Because I can have that equation x plus y plus z equals 6. 1 plus 2 plus 3 is 6. So these are all the ones in the matrix. But sir?
Is there a reason, because I just noticed, like, our inputs have been, like 5x4s and and our outputs have been sort of like matrices?
No, your outputs are going to be the same dimension as the original. So the output will always be the same as what you put in.
Okay.
So count your dimensions more carefully. They don't come to
It's not the same thing.
All right, we got one more to do here, folks. Come on.
This is a big one.
This is a big one. But wait a second. It looks like we have A, B, C, D. All right, so go ahead. You don't need my help. You can do this. And I don't think there's any zeros in this one. Oh, this is it. Oh, my kids are always making fun of me because I don't text with both hands. I wish I need to practice that because it'll make this process a lot faster. Someday you'll be old, Reese, and you'll do things different too.
Oh, there they are.
Did you get some decimals?
Yeah.
All right, let's talk about that. Let's talk about that. Because I don't want you rounding these off. So I want everybody to get to the RREF matrix. Everybody get there? If you come up with decimals like 0.5, that's fine. But when you get these big ones that go on and on and on, we don't want that. So press your math button. Look where my finger is, right here. This finger right here, the button that says math. Press it, and then enter, and it will change them into fractions for you. So the matrix that comes out, and you might have to go across to see all of it. That's okay. Dee? Does that look like what you got? Okay, this is not good news because the whole bottom row has disappeared. So that means we have infinitely many solutions again. And we start from the bottom and work up. So the bottom literally says 0D, remember that's D, 0D equals 0, which means D is anything. Now what does C say? Well, the middle, or the third row here says C plus 3/11ths D equals negative 7/11ths,
Yes.
right? So C equals negative 7/11ths minus 3/11ths D. B plus 5D equals 5. B, 5D equals 5. So B equals 5 minus 5D. And finally, A minus 38/11ths D equals negative 3/11ths. So A equals negative 3/11ths plus 38/11ths D. So far, everybody's still on board here? Because now we have to write our answer. So this time, our answer will be A, B, C, D. So set of a matrix, A, B, C, D, whatever variables you got. And then it's going to have two parts. A regular number, and then in this case, a D part. D is called our parameter. That's a word that we've talked about before. So A is negative 3/11ths, that its number part is negative 3/11ths, and its D part is 38/11ths. So that's A, right across the top. And then B is 5 minus 5D. C is negative 7/11ths minus 3/11ths D. Just keep them lined up there. And then let's not miss that last one. This is, the number part is 0, and the D part is 1, right? It has 1 D, and it has no number. This is called the general solution. The general solution. This describes every possible answer. Now, how many answers is this? This is infinitely many. If you wanted a specific solution, all you have to do is pick a value of D. And then you can figure out your A, B, and C. The easiest D to pick is 0. Because if you let D be 0, that's gone, and wouldn't D's be your solutions? But you could let D be 1, 5, negative root 17, I don't care. You can let D be anything to get a specific solution. Okay? All right. We are going to do one more problem. 7.3 will be due on Friday. We're going to do one more problem, and then I promise that's it. So we're going to do 7.4, the first one in 7.4. You are going to find this the most interesting thing we have done all day. I don't know if it's all you.
It's not hardly the most interesting thing of my day.
All right, what I want you to do is just draw your triangle. You don't have to plot the points. just randomly put them up there, label them A, B, and C. Okay? And now we're gonna do something that is a little bit new to us because we skipped chapter 6, but it's easy. We're gonna describe two sides of this triangle as vectors. So this right here is a vector. We're going from A to B. We're gonna think of that as a vector. Super simple. In the X direction, I'm going from 1 to 3. So that's positive 2. From 1 to 3 is positive 2. Now in the Y direction, I'm going from negative 1 to 2. What would that be? 3. Think about taking steps on a number line. If you're confused, if you're on your number line and you're at negative 1 and you're going to 2, that's 1, 2, 3, right? That's what we're doing. All right, now do the same thing for A to C. Now 1 to negative 1, negative 2 steps. Negative 1 to 7 is 8 steps. Now, I'm a creature of habit. I always use AB and AC. You could use BA and BC, or you could use CB and CA. It doesn't matter which vectors, which sides you pick. Okay, now once you have those guys built, hang on to your hats, folks. We're gonna make a determinant. So I'm just gonna slide them over, lose the parentheses and commas and stuff, and just slide them over. Now I want you to evaluate that determinant. You know how to do that, hopefully. You have a quiz over it. That determinant would be 16 minus negative 6. 22. You did it wrong? Great. I did it wrong once too. Failed that quiz. Did I tell you that story? Oh yeah. Yep.
I don't believe it.
Nope, I did. I failed 2 quizzes in my life, and interestingly enough, they were both in, well, one was in high school, one was in middle school, and they were in the subjects I majored in. So I failed 1 math quiz, and I failed 1 English quiz. And the math quiz I failed in 9th grade was determinants. And instead of multiplying,
You added?
no, I knew I had to multiply and subtract. So I subtracted these, and then multiplied the answers. And of course that was all wrong, so I missed every problem, got an F.
You still lose sleep on your day.
It's still
But you came back better than ever.
But the worst one was the English quiz I failed. 7th grade, celebrated jumping frog of Calaveras County, written by Mark Twain. We had homework, read it. Next day, God bless her, Mrs. Searfoss gave us a quiz. Guess who hadn't read it? So that's another F. And I'll never forget, I mean, this is 7th grade. How old are you in 7th grade? I mean, what is this, 50 years ago? And I remember, like yesterday, after class, she answered all the quizzes. I, of course, got a 0, F. I think maybe I guessed something right, so I maybe got a 2 on it or something, I don't know. But she called me up after class and she said, all she said to me was, she looked at me and she said, Lisa, I expect better.
Oh, I would have cried.
I did.
Oh, I would have involved.
Yep.
I would have stayed there.
Okay. Now, so back to the problem. We're almost done. We have built vectors. We've created a determinant. We evaluated and got 22. The area of the triangle, folks, is 11. The area of the triangle is half the determinant. When you find the area of a triangle, isn't there always a half involved? Half base times height, half side, side, sine. Hero's formula is half the perimeter. There's always a half. So after you have found the determinant, you're gonna divide it by 2, and that will be the area of the triangles. Now, further blow your mind. If this had been a parallelogram, the area of the triangle would be, or the area of the parallelogram would be 22. If you're doing the whole parallelogram, you don't divide by 2 because you want both triangles, or if you want the triangle. Tell me you're not impressed with that.
That is cool.
Very, very cool.
The most interesting thing is